Yeah, so the question is, you are given an array, integer array, nums, and you have to return a new counts array. The counts array has the property where counts of I is the number of smaller elements to the right of some nums of I. So basically, I'll just use the example given. So if you have the numbers 5, 2, 6, 1, for each index you have to say the number of elements to the right which are smaller than it. So for the case of 5 there is 2, there is 1, so the answer would be 2. For the case of 2 there is just 1 which is smaller to it towards its right, so that's 1. For 6 again 1, and for 1 it's 0. So if you think very what do you say, a very preliminary or a brute force approach would be that you just take each element list and you maintain a sorted array or list. Like we take one, and there's only one place where you can put it, and there are no elements smaller than it, so that's 0. And then we take 6, and we want to keep it sorted, something like insertion sort. So we would just keep it, would place it here, and there's only one element smaller than it, then that's 1. When we want to place 2, again we would have to place it here, so that would place 2 here, and then again there's only one element smaller to it, so again 1. And then for 5 we would again have to place it here, but there are two elements smaller to it, so it would be like 1, 2, 5, and 6. So for each element we would have to, in the worst case, mm, traverse the entire sorted list, so that would take around O of n time, and we would have to do this for an element. So this would, we could put a upper bound of O(n) square to this approach, which is not good for the current um, constraints we are given, which is where n is 10 to the power 5, so it would be very slow. Uh, we also could use a existing data structure, which we call the policy-based data structures in C++, which are basically which is basically called an ordered set. Yeah, ordered set. Uh, it's basically similar to a set where you input elements, you insert elements to the set, and they are uh, available to you in a sorted fashion. Additional to that, unlike a set, it also provides indexing, that you could like find the index of a particular element. Like for example, if you would insert all these elements to the ordered set, you would have 1, 2, 5, and 6, and you could find the index of 5, similarly 2 or 6, or also of a number which is not available in this set, but say for example 4. But if it would be in this set, then where would it be? So it would be somewhere here, so its index would be, considering zero based indexing, it would be 2. So yeah, this is easily available on, we could just import a few libraries and we could implement this. So I'll just show you the Geeks for Geeks article on this. So the function, I guess, is order of key which we are looking for. We could use this, and I think the complexity is logarithmic. So yeah, like it's mentioned here, it's logarithmic times. So for each element, it would take upon log of n time to insert, and then log of n time to query also. Um, so we could say that this approach is, we could say that this approach, the ordered set approach, is O of n log n. And that this is pretty decent for our given problem, but there's in interview scenarios, I'm not sure if just using an existing data structure like an ordered set would suffice. Uh, in my interview, I did not answer using an ordered set. Oh, and the answer which I gave was also not very satisfactory. So let's not talk about it. Um, so we could just look at the constraints and think about how we could, you know, solve it. So the numbers, the constraint is like from 10 to the power minus 10 to the power 4 to positive 10 to the power 4, which is basically the number of elements we have is around 2 into 10 to the power 4. Um, like just imagine we put the numbers on a number line, the numbers we have, and let's say we just stored the frequency of each number we have seen till now. Let's say just start with minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5. Okay. So let's say we start from the right to left. So we have a 1. So we have 1 here. And then, so what's the point of doing this? When I place 1 here, so if I take if I take a sum of the frequencies from of this range, it will tell me the number of elements present in this range. Okay, so if I take a if I take a frequency sum, let's say from the minimum number to the current number, so it will tell me, let's say not the current number, but the number smaller than the current number. So it will tell me the number of elements present in the given in the current set, which is a smaller, which are smaller than the present number on my screen. And I think that's what we're looking for, right? Yeah. Mm. So for in this case, like when I enter 1, so there are no elements smaller than it. So the answer for it for 1 would be 0. And then when I enter 2, so now when I take a sum till 2, so there are like till this point there is one element present. So for 2 I would get 1 again. Now I'm going to enter 6. So when I enter 6 here, till 6 there are only two elements present. Mind you, 5 is has not yet been inputted into this list which I have on the screen. So till now there are only two elements smaller than 6 which are available. So again the answer was 6. Sorry, I made a mistake. I input 2 before 6. I should not have done that. So yeah, I just let's do this on a fresh screen. So yeah, again, this is minus 6. Let's start from minus 2, minus 1, 0, 1, 2, 3, 4, 5, and 6. Correct. So initially, when I have to insert 1, I see the sum of the frequencies still uh, less than 1, so 0, and till this point there are no elements. So for 1 we have 0, and we just enter 1 here. Now for the next element is 6, so we are till less than 6, so basically 5. We just have one element till now, so we can just say that till 6 it's 1. So now we enter 6 also, and now when we get 2, we enter 2. Before 2 we just have one element, so for 2 we now again get 1, and we'll enter 2 here. And for now when we want to enter 5, we see till 4 how many elements are present, and if we do a sum we'll get only 2. So 5 we get 2, and we enter it here. And now let's just add another number. So what happens if I add, let's say 6 again? So if we have 6 again, so now when I enter 6, so it has like 3 numbers here, so we'll have 3 for 6. So I think you get the idea. So what we need to do is, for each operation, first we need to do a sum from 0 till x minus 1, where x is the ith number. So x is equals to num at I. Okay, so this is x. So for each iteration, we need to find the sum of 0 to x minus 1. And this sum is not on the nums array, but it's on the new array which we have created, uh, where we are storing the frequency of each number. And the range would be from minus 10 to the power 4 to positive 10 to the power 4. So yeah, sorry, it should not be a 0, it should be the minimum value. And in this case, minimum value is equals to minus 10 to the power 4. Yeah. So it should be minimum to x to the power minus 1. Yeah. No, sorry, not x to the power minus 1, x minus 1. And after we have done that, we need to add that we need to increase the frequency of x by 1. So after doing this, we need to increase, let's, do we have the space? Yeah, let's undo this. So yeah, after this, we need to increase the frequency of x by 1. Okay. So this, so yeah, basically I just write it here. First, we need to get sum from min to x minus 1, and then second we need to get the frequency, we need to just update the frequency by 1. So uh, if you have seen such problems before where we are doing a range query and then point update, uh, I think you would think about segment trees or fenwick trees. So yeah, I think we can also solve this problem using a segment tree. Like we can build a segment tree uh, on the range we are given. We would have to, shift this to the positive range, because unfortunately we are dealing with negative indices. Indices won't be possible. So we could just shift it. We could just add 10 to the power 4 to each frequency and then do the appropriate adjustments later. So like the range would be from, let's say, 0 to 10 to the power 2 into 10 to the power 4. Yeah, this would be a range. So we can build a segment tree on this, and initially the frequency of each index would be 0. And as we encounter each number, we would just increase the frequency, or we would increase the frequency after we have done the sum query. So yeah, I think we're good to go, and we can just go ahead and implement this. So we can just make some constants, like this would be int. The maximum size would be 2 into, we can just write it as 2e4, I guess. That should do it. And we can, so safely to create a segment tree, we create it, 4 times the number of elements. So let's just go ahead and do that. So int seg 4 into n, that should do it. And we don't need to build it, because initially all the values should be 0. So we don't need to worry about that. A function which we need to implement is update. So void update, and what we would need is, okay, so I'm assuming that all of you understand what a segment tree is. If you don't, then you must, I think, spend some time understanding what a segment tree is. So you could open CP algorithms or Geeks for Geeks and try to understand that. I'm sure plenty of videos are also available on YouTube. So moving on. So what we need to do is, uh, yeah, we just implement two functions. Update, like I mentioned before, the function which would increase the frequency, and then currently let's just implement update. So yeah, this would be the node. We would also need the beginning, the end, and also the value. I guess I think that's enough. I haven't, you know, written a segment tree in a long time, so I'm not very sure if this. Let's just see if it works. So what we do is, we take a tree, um, we go down the tree, and if, okay, so obviously we need the position, and just the value won't work. So we also need the position. Yeah, so we go down the tree, and if the position lies in a, if we just, yeah, reach to the, yeah, if the, what is it? Yeah, if the position lies in the scope, we do the corresponding update. I think that should work. Yeah. So if big equal and big equal pause. Yeah, I think that's, so big and end is the indices in the initial array. Yeah, so that should, yeah, that should be, and that should do it. So big and end. hmm So big equal and big equal pause. So what we should do is we should update that position. So what we would do is seg and nd. We would just increment it by, we could just increment it by one. Yeah, I think that's it. I think this should be handled separately, uh, because if beg equal end we have reached leaf node, and if it is the one we are looking for, then we can do this. Otherwise, and in this case val is not really required because every time we'll be incrementing the frequencies by one, so we can just let go of val here because it's not really required. And here we can just return because there's nothing else we need to do here. Now once we are done with that, we could, uh, if the position does not belong to the range, so there is no update that would be here. So if position is greater than end, or position is less than big, so I don't think we need to bother updating. Otherwise, the, since it's a sum, so the sum of nd would equals to, we would just update the left tree and the right tree. So the left would be nd into 2, I guess. Yeah, we have we'll be using indexing starting from 1, so yeah, into 2 should work. And then beginning, and we also should write the mid, and then, yeah, position. Similarly update and nd into 2 plus 1, and then mid plus 1, and end, and then again the position. So we need to define mid, which is into mid is equals to beg plus and divided by 2. I think that should work. Now once we have updated the left and right subtrees, we can use their values to update my current uh, node, which is seg of nd into 2 plus seg of nd into 2 plus, I think I have not messed up, and this should work. Okay, yeah, and the next function which we would need to implement would be the query function. So I could just write get sum, and it would again be of the same pattern. We would take the index of the node in the tree, the range it corresponds to, and also uh, the range we are looking for. And in this case, L would always be the minimum value, but just let's just write it in a very generic fashion. So, so yeah, if your range L is just, let's just say it's just outside uh, the scope of the current node, so we can easily just return 0. So if L is greater than end, or if R is less than beg, that just means that we are just out of the range. We can just go ahead and return 0 safely, no problems there. Yeah, and if, what else, um, what if the range is the range query range is entirely inside the the node range, then what should I do? I can just go ahead and return it, right? So if uh, beg is greater than equals to L and end is less than equals to R, that means the this entire range again we just returned, and so I'll just return this, and no worries there. Otherwise I would have to get, so we would return get sum of nd into 2 comma beg comma mid comma l comma r plus get sum nd into 2 plus 1 mid plus 1 comma end comma l comma r. Okay, I think that should, let's see if that works. So yeah, now what I need to return is a vector. Let's just name it as it's given counts. It would be of size n, and it would initially, let's not just give it any, let's just not give any value, and we need to define n. N is nums dot size. Okay, so like I said, the values given to us would be from minus 10 to the power 4 to positive 10 to the power 4. We just need to just shift them towards the positive axis. So we'll just add 10 to the power 4 to each number. So we can just define, I just write it add, just write add is equals to 1e4. Okay, so now for int I is equals to 0 is then an I plus plus counts of I. So the counts of I, so that's a mistake. We need to traverse from right to left, not from left to right. So yeah, that's a mistake. Thank God I noticed it. So counts of I would be get sum. So the minimum value is 0 in this case because we have shifted it towards the right, and the maximum value would be counts of, sorry, not counts, nums of I. Remember, we are adding add to it and just subtracting 1 because we don't need it, just smaller than that, not equal to it. Number of elements exactly smaller, not equal. Okay, yeah, that's done. And now we need to just update it. So update, and yeah, this I'm starting with 1, not 0. 1, and the range would be 0, and the maximum would be n. Wait, n, right? And the maximum is n, correct? And the position would be nums of I plus add. I should have just initially add to all the elements. Would have been much easier. Never mind. Let's just return counts and see if this works. I'm highly skeptical this will work. I'm looking for that error message. Come on, give me an error. Correct. So there's this error. Invalid use of non-static data member. So what's wrong here? What did I do? This is it not done this way? Should I make it static? So it should not be void. Definitely should not be void. It should be int. Okay, let's see. One more chance. Okay, another error. Expected too few arguments. So get sum has too few arguments. Yeah, obviously it has too few arguments. This is not the range we are looking for. Yeah, so 0 to n. The beginning is 0 and the end is n, and the range is again 0 to nums of I plus add minus 1. Okay, correct. Okay, so this is accepted. Let's just take a chance and submit this. Would this work? Brilliant, 96.3%. So yeah,